My name is Alex Hazlett. I am a mechanical engineering major at the University of Dayton. And pretty much all of my life, and especially in high school, I've been interested in how things work, particularly mechanical systems. And that was really solidified with my experience in FIRST Robotics, which basically you had to design and build a robot within 6 weeks that could move around and perform a task. And I found that I really had a passion and I really enjoyed doing that sort of a work. And recently I got started as a co-op at Rhinestahl, and in particular Rhinestahl ITS, the Innovative Technical Solutions section, which is focused on design and build, and recently has been going into additive manufacturing. So the Rhinestahl Corporation has its heritage in aerospace tooling and is pushing into advanced technology. It has 3 business units. There is AMG, which is the Advanced Manufacturing Group. They focus on precision manufacturing of complex parts to specifications. There is the CTS, which is the Customer Tooling Solutions. They focus on tooling for maintenance, repair, and overhaul for the aerospace industry. And then there's ITS, which is the Innovative Technical Solutions, which is where I am particularly co-oping. They are focused on design and build, sustainment, and now are pursuing additive manufacturing. What I really like about my particular co-op assignment is that I'm really able to dive into what I'm interested in. So in the first few weeks, I was able to work with design work, do meaningful activities within the company, but at the same time, Rhinestahl actively recognizes that the co-ops are there to learn. So they're willing to invest in you and help you to develop the skills that you want to develop. You can go to your boss and ask him questions, say, hey, how do I do such and such? Or, oh, can I help you do this thing? And they'll actually structure your work assignment to what you want to do. Additive manufacturing is an exciting new field within manufacturing that has been referred to as the next industrial revolution. In the past, you always had to worry about how you would actually make the thing. So you would have to be able to get your drill bit in there or be able to machine out things or how you would weld things together. With additive, you build up your part layer by layer by layer. Pretty much anything that you can build in a 3D modeling tool like SolidWorks, Inventor, or that sort of a thing, you can pretty much 3D print. And that includes things that you just couldn't physically do before. Like you could have a structural piece that actually has an internal lattice structure that produces weight, which for the aerospace industry is really rather useful. So within the first week of my co-op, I noticed that I had an interest in the 3D modeling, and Rhinestahl also noticed that, so I was given an assignment to design some giveaways. So I went into SolidWorks and I started out by creating this thing here, which was the basic idea, which had a cylinder with a cube inside of it, and inside of that was a sphere. Within a day or two, we had printed this out, looked at it, and realized, oh, we want to do some different things. So like several iterations later, we came to several different sorts of things. So like this is one that we did for CTS, which again, it has things floating inside of other things, which again, you cannot do with a subtractive method. It's totally inconceivable. And yet nowadays with additive, you can print this out in a matter of like 10 hours. This is one we did for ITS, which again, it has a thing inside that spins when you turn something on the outside, and it's just really amazing what you can manage to do with additive manufacturing, and it's just going to get better. It's just going to get more complicated and more interesting, and you're going to get so much more capabilities going forward.